Hi there. In this video I'm gonna talk about the basis of region growing. So to understand what that is, let me draw an 8 by 8 image to make the idea clear. So basically this method is based on defining seeds, and then from these seeds we grow the region based on a similarity criteria. Okay, so let's say that this pixel here is this seed I chose. What I do is just I evaluate the surrounding pixels for a similarity criteria or criterion, which I defined in the previous video as the predicate. Okay, so the predicate of a region Ri must be equal true. That is, all pixels in that region Ri must satisfy a predicate or a similarity criteria or criterion. So here I can evaluate these 8 pixels that surround the seed point, and if they do, if a given pixel from these surroundings satisfy the predicate, then I just include it with this seed. Okay, so let's say that this one, and this one satisfy the predicate I defined. So in this case I consider that this is my grown region. Okay, and this is my grown region, and this is why it is called region growing, because we grow the region starting from a seed using a similarity criterion. Okay, and then what I do next is I consider again the pixels surrounding this this region. Okay, and I do that until I converge. Now, about the choice of the seeds, of course, we do not just choose them in a random way. There are methods that we can use to define the seeds when we do not have any prior knowledge about the segmentation problem. But if we do have some prior knowledge, then it is better, and we can use that in our advantage to define where the seeds should be. Just to give you an idea about what that is, let's consider that I want to detect well defects. Okay, so well defects we usually use to detect them X-ray images. Okay, so we use X-ray images, and the prior knowledge in this case is that the well defects have a very high reflectance for X-ray waves. Okay, so this means that I can define these seeds as the pixels whose value is very high or maximum. So I can say, for example, take all the pixels with the value 255 for an 8-bit image as a seed point, and then start to grow the region from these seed points based on the intensity level. Okay, this is an example about how we do region growing. About the choice of the predicate, we do it based on the not only based on the problem at hand, but also upon the type of data. For example, in this case we have X-ray images, so it makes no sense to go and define a predicate based on the color. So the point is, the choice of the predicate depend both upon the problem at hand and also the type of data. Now, one thing that I didn't discuss in detail is the stopping rule. Okay, so when do we stop? So usually we stop when there is no pixel in the image that can satisfy the predicate or the similarity criteria we defined. Okay, but sometimes this similarity criterion or criteria may not take into account the history of the grown region. I mean, let's say that I use, for example, as a similarity criteria color or intensity level. So in this case, we do not take into account the previous pixels that we included in the ground region. And when we define criterion that take into account this history, we get usually better results. So some criterion that we can use to include the history of the ground region is the mean of the ground region, probably the area, and also the shape, okay, the shape of the ground region. So if the area, for example, here, if the area reaches a given point, or if the shape takes a given form, then we stop the process of growing this region. And in this case, again, the case of including history criteria, we need to have information, prior information about the problem, because how are we supposed to know what shape to define if I do not know the form of my segment? So prior knowledge is very important to get very good segmentation results.